So we try to find the local maximum, local minimum values, and the set points. Okay, so here's a function. Oops. Yeah, that's enough. Here's a function f of x, y is going to be x minus y, 1 minus xy. Okay. Find the local maximum and minimum value, and the set point. When we say points, that means you have to give me the coordinates of the point. So there are limited space. So it depends on how much space, how large is the letter you want to write. So we have to find out critical numbers. So the function smallest differentiable is defined on the whole plane. Okay. And so how to differentiate, right? You have to multiply this out. Otherwise, it's hard to do that, right? Well, it's maybe not. It's product, right? So let's multiply this out. I don't know which is better. Sometimes you don't need to multiply this out. You still find the derivative. So it's going to be x minus y minus and x squared y and plus xy squared. Okay. So find the partial derivative. It's going to be 1 minus 2xy and plus y squared. Okay, and another one, it's going to be -1 minus x squared plus 2xy. So we are going to find the solutions, right? So it's not easy to find the solutions here. So what they do is that equation 1, equation 2, those are two algebraic equations. They're not linear equations. There's no standard way to show you how to do this, how to solve equations. So trying to eliminate the variables if possible. When I look at that, you find out negative 2xy, positive xy. So it's very natural idea, just add them together. One negative one is gone, right? So what you get here is going to be just negative x squared plus y squared equals 0. Of course, there's still two variables there, but this equation is simple. So I can tell that x equals, y equals x plus minus, y equals plus minus x. Okay, so that then y equals plus minus x. So you can case 1, case 2, yeah, case 1, y equals x to see if we can get solutions. I put put x for y into the first equation. Okay, go to the first equation, 1 minus 2x, y is x, so x squared plus x squared, which is going to be, right, x squared equals 1. So that implies x equals plus minus 1. So then, the y is also plus minus the same value, right? Same sign. So you can quickly get those. In case 2, y equals negative x. Then you still use the first equation, okay? If we use the first equation, it's 1 minus, here's plus 2x squared. And then also here's x squared, right? Because negative x squared is still x squared. But negative 2x times negative x is positive. This is going to be 0. No solution. Right? X cannot be negative. X squared cannot be negative. So no solution. So you only got 2 sets of solutions. But you have to find the second derivative. The matrix, right? The matrix, when you differentiate with respect to x, you get negative 2y and fxy. And then you differentiate with respect to y, you get negative 2x plus 2y, okay? Then fyx is still the same. Fyx is negative 2x plus 2y, okay? then f of y, and that is going to be 2x. Okay, so you have to evaluate the matrix at the point when x equals 1, y equals 1. I just don't want to write down all the details. That's just matrix, okay? You know, you put them into a matrix. You took math 171, so you know what is matrix. So when x equals 1, y equals 1, and that is, yeah, that's going to be 0 because I have the same signs. Those always cancel out. And this is a 2. So clearly, it has a negative, the determinant is negative, right? So this implies that the determinant is going to be negative, -4. So negative the eigenvalues have opposite sign. Okay, in the book, the theorem says that without telling you what's going on here. Just memorize that d equals. If it's negative, it's harder to have a connection, you know, between the picture and the signs of the determinant. But this is a matrix. So imagine the graph where it looks like a -2x squared plus 2y squared. So this is it's a center point, okay? Center point. So for the center point, you have to write down the coordinates, right? So 1 and 1, okay? Then when x equals -1, y equals -1, you will probably get the same answer, right? And y is equals -1, it's +2, 0, 0, -2, okay? This is again implies the determinant is -4, it's negative, and center point. Okay, so center point gets this. Yeah, this is the answer. You know, if you get another matrix, you just need to check whether this has a positive, both are positive eigenvalues or has a positive negative. I think I use the eigenvalues that much better than the first A11s and determinant. Okay, so it's first second so basically if the function, let me say that if the function if the matrix, you know, the first case, if the matrix has both negative eigenvalues, then the function has a local maximum value. If both eigenvalues are positive, the function has a local minimum value, okay? And then if the eigenvalues have an opposite sign, then you get to add the center point. Okay. So this is this is the idea. You know, for example, if the function f of x, y, right? The simplifying case is λ1 x squared plus λ2 y squared, right? That's the simplest case, right? So this is simplest case, and clearly, if λ1, λ2 both are positive, then f has a local minimum value, right, at the origin. So if λ1, λ2 are both negative, then f has a local maximum value because it's parabola that opens downward. So you have a highest point. Okay. Now, if λ1, λ2 have the opposite sign, and one is negative, the other one is positive, then the graph is the origin looks like a center point. Okay. Then 0, 0 is a center point. Okay. So this is a key point. So the function, if you get a matrix and the matrix has eigenvalues, right, lambda, λ2. So after transformation, you can change the function to a function looks like that. So that's the idea. Now in linear algebra, how do you know a matrix has a positive eigenvalues then there's it's easy to see from the for example AB and A11, A12. We can use a symmetric matrix. Yeah. So if we have A and the B and B and the C, some matrices like that, right? Of course, you can get, after simplifying, you can get eigenvalues in lambda 2. So how do you know those two eigenvalues are both positive? Then you can see that lambda 1, lambda 2 are both positive if and only if A is positive and the determinant of this matrix, which is AC minus B squared, is positive. Okay, so that's why it's linear algebra. It's coming from linear algebra. Okay, so the key, but essential part is both eigenvalues positive. Otherwise, you have no idea why this. Okay, well, if this is true, then you get local minimum point. Okay, because this is coming from linear algebra. A symmetric matrix can be simplified to a diagonal matrix was just only numbers on the diagonal. The rest of them are just 0. Okay, and then lambda 1, lambda 2, and they're both negative if only if the first one is negative. But the second one is still positive because lambda 1 times lambda 2 is positive. Okay? And opposite sign means as long as the determinant is negative, then they have the opposite sign. Okay? So that's, but our matrix here is already simplified matrix on the diagonal. Okay? All right, so this is a good problem. Yeah, you need more space. You have to, if you write clearly, you still need more space. First of all, there's a space given. You can only find the critical points, but you still have to look at the matrix. For the test, yeah, there will be always 10 problems, and maybe the wording of some problems will be changed a little bit, but most of cases I just change the function, the data, given in the problem. You're still going to do the same type of problems. Okay? So the first type of problem is to find the parametric equation for the tangent line to a curve. So the curve is given, and you still probably have to find the value of t. So find we can let's try that. Find the parametric equations, right, for the tangent line, right, to the curve. So the curve are given by parametric equations. Now sometimes it's given by the vector function, right? It's possible. So natural log of t plus 1, y equals natural log, not natural log, y equals t times cosine 2t, z equals 2 to the t. Now at the point 0, 0, 1. So at that particular point, you have to figure out the value of t. At which point, but that can be seen easily from those functions. So this is going to be at t equals 0. Okay, at t when t equals 0, yeah, this is a there's a curve passes through that point 0, 0, 1. So you can you should express it as a vector function, right? So this is a t cosine 2t. and 2 to the t. So all you need to do is to find the tangent vector to the curve. If you know get tangent vector, then you can write down the vector function for the tangent line. Okay, so differentiate, you get 1 over t plus 1, and this one is going to be cosine 2t minus t sine 2t, and there is 2 here in front of that, and then here's 2t natural log of 2. All right, now you have to clearly write down all the details, because you cannot guarantee all your computation is correct. When you differentiate some function, maybe you can make mistakes. So yeah, you should try to write down all the details. So this is going to be 1 when t equals 0. The second part is 1, and here natural log of 2. So this is a tangent vector. Once you have a vector, a point, right? You can if you have a tangent vector, then you can draw find the equation for the straight line. Right? Find the equation for the straight line. I think I should use a different notation for the for that one. You know, you can yeah. So yeah. So the straight line, you can use a vector function to describe it. Then you write down the formula for the write down the parametric equations later. Yeah. So this is a point, right? And then an arbitrary point. So we can use any like use the F for the arrow symbol there. Okay. So F of S is that and plus S and of this tangent vector. So this is a general. This is a maybe ask you to find the vector function for the straight line. Okay. Now, if you want to write down details, and the x s is going to be 0 plus s, ys is 0 plus s, ds is going to be 1 plus s times natural. Okay, that's correct. Okay. The key point for this problem is just you should know how to find the tangent vector to the curve. Now it's possible I will ask you, can you find the points on the curve so the tangent vector is parallel to the xy plane, something like that. And it'll be slightly different problem, but you still should know how to find the tangent vector to the curve. Then you're trying to determine the value of t so that the tangent vector is parallel to the xy plane. Now, when you say parallel to xy plane, means the third component should be 0, the tangent vector, right? Otherwise, how is it parallel to the xy plane? Okay. So if I ask you to so the next problem, I have to carefully select the function, because otherwise you are not able to evaluate. When you're trying to find the length of the curve, the most important thing is you have to set up the integral, right? Then do your best to evaluate it. But not always, it's going to be possible, right? So t is between 1 and 4, that this is a function. So write down the formula, right? What is the formula? Okay. Now she did it correctly, but the formula she didn't write down, it's incomplete. Okay, right? Yeah, the rest of them is correct, but don't be lazy. Yeah, so write down the formula. So L equals the length, it's integral. You put the 1 and the 4 here, and then this should be the norm, the length of the derivative. Yeah, this should be the correct formula. Okay, don't ignore some parts. Okay, complete the formula. So it's clear to me. You're going. In general formula, maybe you can put A, B here because it's nothing specified right now. Yeah, and this is a formula. We know that. So now let's find out the derivative. You get. I'm going to use the arrow symbol. Yeah. So it's going to be 2t, and this is a 9t, so it's 9. Okay. And the next one is 4 times 3 over 2, so it's 6 to the 1/2. 6 times, I think it's 6, yeah. Okay. All right, so that's a derivative. Now, if you are not able to evaluate integral, you double check your derivatives. Okay, maybe that was a computation mistakes here. Okay, so this is a formula. Then you try to simplify this. Find that before you put it in integral. It's going to be 2t squared, 9 squared, and then 6t to the 1/2 squared. Okay, we hope that we can write it as a square. So 36t. All right. Yeah. So this should be equal to, if it's a square, right? This should be 9 clearly, right? Because, right? And this should be 2t. Otherwise, you're not able to get 4t squared. Then you double check. Do you get 36? Yes. And that. Okay. Now, if you're not able to write the square, more likely, some computation mistakes in the derivatives. So then you have a 2t plus 9. Okay. Yeah, how do you determine, it's complicated quadratic question, but you just needed to look at as a constant and the leading term, 4t squared. 4t squared is coming from 2t squared. So it should be, if it is something square, it should be 2t plus 9 or 2t minus 9, right? Yeah. All right, so then the length is going to be integral from 1 to 4, 2t plus 9 dt, and the entire derivative. Okay, the rest of them is simple. 4 squared plus 9 times 4 minus 1 squared plus 9. Okay, so you can simplify as 16, 36 minus 10. Okay, so that's easy to see that 52 minus 10 is going to be 42. Okay, so this is the integer. So remember, right, if I ask you to find the length of the curve, you should be able to evaluate the integral. Okay, but at least you should simplify the integral to some point. Maybe you forgot some special formula, for the integral. So, and you stop there, you should move on. Look, if it's time is limit. You don't spend like 20 minutes on one particular problem. Okay. Maybe you later on, if you have time, you go back to check whether your computation is correct. Okay. Third problem is, I think this problem is easy. You are given the acceleration, right? And you just need to find out the position function. Okay. So we have the initial velocity. It's going to be negative 2k, and initial position plus 4k. Okay, we want to find out the position factor, the formula, right? So just do step by step. So Vt is going to be integral of acceleration, right? And it starts from yeah, the formula you can write on the formula. It starts from first of all, yeah, just integral, but you determine the coefficients later. Let's do this way. Okay, I'm not getting into the integral. So this is the integral, and we're determining the coefficients later. So integral of sine t is going to be cosine t I. Integral the negative cosine t. Then this will be negative sine t, and this will be 3 over 2t squared, and k. Okay. Plus constant. Okay. We needed to determine the constant. Okay. I know that when t equals 0, okay, when t equals 0, you get negative 2k, right? And then when this is negative I, that's it, and the plus c equals 0. So that c is going to be I, right? So just 1 minus cosine t. You can write down the formula. Yeah, you can do later together, but I prefer to find the velocity function first. Right. Then I evaluate the integral of the velocity vector. Okay. So what gives you the integral of the first one is t minus sine t I, and this cosine t j, and this will be half of t cubed k, and plus another vector c. Okay. Then you again you plug 0 for t, you get j plus 4k. J plus 4k. So when you put t here, and this is a j, 4k. It's minus, no, it's nothing there. So c is going to be negative j. Okay. So once you get c, then you can get to the general formula. Negative plus negative 1 plus cosine t j. Right. That's it. Wait a minute, it's 4k, right? Hold on. 4k. So we have minus 4k. This is so my computation mistakes. All right. So we're trying to. It's not equal to 0. This is a. So this is a negative 4k. Right. So this is negative 4k, and I have a nothing here. Right. C is negative 4k. So there was a negative sign here. I think, yeah, that's the only term here. C, sorry, C is negative positive 4k plus 4 minus half of t cubed. That's correct. Yes. Yes. Okay. So just determine the coefficients when t equals 0, and you find out the first term is 0, second term is jj, and third term is 0, j plus k. But you want to get j plus 4k, so c must be 4k. Right. So then you write down the general formula for this. This is not a difficult problem, but it's easy to make mistakes. Okay. So next problem, we did we probably did that for the home for the quiz. So next problem is we're going to draw a contour map, right, of the function f of xy equals. When you draw the picture, you should at least, when you say several level curves, means minimum 3. You cannot just draw 1 or 2. Okay. So this is the equation is going to be like that. Okay, draw the curve for different values of k. Right, for different values of k. So when you look at this equation, right? So that means square of x plus 3y equals k. How to draw the graph, right? It's y equals negative 1/3 square of x, right? And plus k over 3. So first of all, it's clear that you have to draw the picture when k equals 0. When k equals 0, this is going to be like that. Okay? This is going to be like that. So this is going to be k equals 0. You have to mark it. What is k equal? You cannot just draw a 3 curve. You have to clearly mark the value of the k. Okay? Then when the value of the k changes, you just shift the graph upward, downward, right? When k equals 3, you just shift the graph upward by 1 unit. Okay, when k equals 3. So k equals 3. Then when k equals -3, you're going to just minus 1, right? So that's good enough. That's good enough. Okay. So how do I know the curve looks like that? When y equals -1/3 the square of x, right? You square it, right? When you square it, you get 1/9x, or x equals 9y squared. This is a parabola. Yeah, opens to the right. That's why it looks like it, but it's only half of the parabola, since x cannot be negative. Okay, x cannot be negative. So the above equation is equivalent to the following equation with a restriction on x. That is why x cannot be y can be negative, positive, but the x, sorry. So this is a but wait a minute. Okay. So y cannot be negative. Y cannot be positive. Y is negative. Okay. Y is negative. Okay. Y cannot be positive. So that's why you can only draw the parabola, the part below the x-axis. Yeah, because from look at the equation, y equals negative square root of 3 over square of x. So y cannot be positive. Okay, and so the graph of this equation is only half of the parabola under the y-axis. Okay, that's it. So don't forget, draw 3 curves, typical curves, minimum. Okay, don't just draw it without the mark it. You have to say which one corresponds to which value. Find the limit if it exists. If it does not exist, you have to prove it. Now, at the moment when I see this rational function, this is a rational function. The degree of the numerator is 3, the degree of the denominator is 2. So the numerator approaches 0 fast than the denominator. So the ratio approaches 0. So it should have a limit. Okay? But if they have the equal degrees, then it's hard to tell, maybe twisted, you know, right, nearby the origin, okay? So don't try to prove the limit that does not exist. You have to prove that the limit exists. In many cases, you do need the following inequality: x times y is going to be absolute over x times y is going to be 2 times that is going to be less than this. Why is this true? Okay, this is called I think it's called Schwarz inequality, and it's trivial because x squared plus y squared minus 2, right? That's going to be absolute x squared, absolute y squared minus 2, right? And everybody knows that this is going to be, that's why it's present here. So that's going to be 0. It's always a positive. Okay, that means x squared plus y squared is greater than or equal to, right? And when does equality hold? Equality holds when those two absolute value are equal. Okay, equality holds if and only if this is going to be 0. That should be the same value. Okay. So this is a proof. Okay. Yeah. Anyway, this inequality is very important, and it's much easier for you to prove, right? So now x squared y, right? You want to prove this is going to be 0, so you take up a absolute value. Okay, make it easier. Okay, this is going to be x, right? X absolute y, right? And this part is smaller than 1/2. Okay. Yeah, how do you prove this is going to be 0? Because I think you can use the Epsilon delta language, but I think here it's easier to see that as x, y approaches 0 and 0, that means x squared plus y squared approaches 0, right? Right. But x squared plus y, that forces x approaches 0, okay? And the y approaches 0, both. Okay, at least it. So that means absolute x over 2 approaches 0. Okay, so this implies approaches 0. Okay, so therefore the limit of this expression is going to be 0. Yeah, x squared plus y squared approaches 0 means the points are getting close to the origin. Well, when they're getting close to the origin, the x coordinate must be getting close to 0. Okay, right? X coordinate is just a projection of the point onto the xy axis. So this is this is argument. Okay. Now, if I change the problem a little bit, then this will be different. For example, I still have x squared y, but I put x cubed y squared. Change a little bit. You're not able to use the above inequality to prove the limit is 0. But when you look at this, the numerator has a degree 3. The denominator has a degree 3. So more likely it's not going to have a limit. Okay? But you have to argue in a nice way. I think the function is even not defined along some lines. So in order to make it defined, I have to put absolute value there. Otherwise, this the denominator is going to be 0 for some points close to the origin, but not at the origin. Now it's okay. Okay, this expression is defined. as long as x, y are not the origin. But even that, still the limit doesn't exist. Okay, you can take a look at, you know, along the x-axis, right? That's the easy part. Then x, y is going to be t and 0, right? Okay, t, let's t goes to 0. Okay, and the expression is going to be 0 because the y value is always 0, so it's approaches 0. Okay, then I have to get something which is not going to be 0. How can I do that? The diagonal along the line y equals x. Okay, then xy could be t like t, and still t goes to 0. Okay, otherwise it's not going to be the point approaches 0. Then the expression is going to be tq plus t squared. Okay. Oops. Are we going to get? Yeah, let me think about it. so this does not work. You will see that it's still going to be 0. Okay, as you see that. So you get t squared, t plus 1, tq, right? So you know what happens. So you will get t over t plus 1. It still goes to 0. Oops, right? Then how do we overcome this problem? Okay, we should try to find something different along a different line. Okay, so we can all right, so let's try a different. We can try square root t and y equals t. Right? So t approaches 0 from positive side, otherwise it's not defined. Okay, then x squared y, I'm going to get t times t. Okay, then this will be t 3 over 2. That will be t squared. Okay, so so let's see if we are able to prove this is going to be a different number. Yeah. So if I take this out, it still approaches 0. This is approaches 0, right? Can you see that, right? Try this, and because in the denominator, you take t to the cube 3 over 2 that is going to be smaller. Yeah, we have to carefully choose a different number. Okay, I'm not going to use a TQ because otherwise it's not working. So I'm going to determine this number later. Okay, so I will get and t to the 2 alpha plus 1 because t 2 alpha plus 1, right? So this will be 3 alpha. That will be t squared. Okay. So we were trying to get something which does not approach 0. Okay. So what you can do is I'm going to divide both sides by the same constant. So here it's going to be 3 alpha plus t squared divided by t to the alpha plus 1. Okay, I'm trying to get non-zero. That's the whole point. So it's going to be t to the alpha minus 1 plus t to the 1 minus 2 alpha. Okay. So make sure one of them is not going to approach 0, right? Okay. So this is going to be so I want to make sure t is going to be greater than, whoa, this is not working at all. So I'll talk about this problem later. I don't think this is going to be the limit possibly convergent to 0. Okay, so alpha minus 1. So no path works well right now. Okay, alpha minus 1, right? You have to make sure both approaches, that both of them, at least one of them approaches a constant, other one approaches 0. So 1 minus 2 alpha should be greater than 0. Yeah, let's see what we can get. Alpha equals 1, it's not working. When alpha equals 1, the t to the negative 1. If t to the negative 1, it approaches infinity, so make the whole thing 0. Okay, so alpha minus 1 should be alpha minus 1 greater than 0, and the 1 minus 2 alpha should be greater than 0. I don't think we're going to have a solution here. Alpha greater than 1 is less than the 1 half. It's not working. All right, so this does not work. So that means along every path, it is going to be 0. And so the question is whether you can, I think this is a difficult one. You have to prove that as an inequality, you can make sure this is going to approach 0. Okay, but this requires more tricks here to prove this is going to be approach, because we try several passes, right? They all approach 0. So this also approaches 0, right? No matter what you can choose, okay? So, so then you have to find a way to prove this inequality. I think this will be I will discuss this later, because this requires a very tricky inequality here, because it's not like x, cannot use a direct argument x square absolute value. Right? It's going to be, if you just use x here, x times y, okay, you are not able to show this can be x squared plus y squared, right? Divided by 2. but you cannot control this. Okay, so I have to change the problem. This is not going to put the example. Okay, it's not easy. It's not all the problems you can easily solve it. Okay, I don't see any simple E encode you can use to prove that this approach is zero. Yeah, I don't think this. I just random pick up a problem. Doesn't mean that just like if I random pick up a function, you're not going to evaluate the integrals. Okay, so let's move on to the next problem. Otherwise, we're not going to have a time. Given f of x, y is x squared, and find this just find the partial derivative. This is pretty straightforward. Okay. All I have to do is just use a quotient rule. Be careful, and that is going to be x plus y squared. Partial derivative with respect to x, so it's 1 x plus y squared minus x times the derivative of x plus y squared with respect to x. So that will be just y squared, x plus y squared and squared. That's the first. And then you differentiate the second one, and that would be at this time the derivative of x is going to be 0. Then you differentiate the second, the x, the denominator will be x plus 2y squared, which is 2y. So the answer will be, that's problem number 6. Now, I'm not sure we have enough time to do all the problems. Okay, let me check what kind of problems I have. Yeah, I want to do the last 2 problems first before we run out of time. But I still, when I get home, I still finish the rest of them and post it. Okay. Yeah. So the problem number 9. Given the function f of x y, sine x times y, find the maximum rate of change of f at the point when 0. How to do this type of problems? I think you have to write down at the very beginning what do you want to find out. Okay, so if you look, if you write down a little bit more, that'd be great. So this is the maximum rate actually is the absolute value of the gradient. Okay, so you can say that the maximum rate, okay, is going to be the absolute the length of this, because it's already proved that in the book. Okay, this is the maximum value of the directional derivative over the whole unit vectors. Okay, so that's the reason their motivation is to find the derivative, right? Otherwise, you don't know why you have to do that, right? So this can be the partial derivative is cosine xy, and that will be y, and cosine xy will be x. Okay, then that will be 0. I think it's just 1. Yeah. So this is yeah. So then you just say it's 0 squared plus 1 squared 1. Right? You have to say that the maximum rate is going to be the length of this gradient. Okay. Now the true idea is why it's called the maximum rate of change, because for any unit vector v, this dvf at 1, 0 is going to be the gradient, right? The product of this. So that is the rate of change in the direction of v, right? This direction derivative is the rate of change of the function at the point in the direction v. So the value of this is always less than equal to, right? And since v is a unit vector, that's the reason it's always equal 1 here, right? So this is the maximum value, and then it can be reached when v is going to be the same direction of the gradient of the function. Okay, that is the idea behind that. Otherwise, why the gradient, the length of the gradient of the function is the maximum rate of change. This is the maximum rate, right? Okay. Okay, so the next, number 10. Find the absolute. Yeah, this is a little bit more complicated. Find the absolute maximum and minimum values. Right? The function is given by x squared minus 2xy plus 2x. It's a rectangular domain. It's a rectangular domain. D is going to be x and y. X is between 0 and 3, and y is between 0 and 2. So this is a closed bounded domain. The function has absolute maximum value or absolute minimum values either at the critical point or on the boundary. Okay. So maybe it's a good idea to state that f attains the absolute extreme value either at critical point in the D or on the boundary. On the boundary, this is a notation boundary, okay? In mathematics. So the boundary is a square. So what I have to do is just find the critical point inside the domain, and then you have to look at the value function at the critical point on the boundary, okay? So let's take a look at the function, the partial derivatives. It's going to be 2x minus 2y and plus 1. And plus 2 here, okay? And that is going to be negative 2x. Now, you don't need to check whether the function has the local maximum value at the critical point, because that's waste of time. We don't need to know that information. Okay, local maximum point, we don't care. We care about the absolute maximum value, absolute minimum value. So when you differentiate this with respect to y value, you only get one term. Differentiate with x value, you get 3 terms. Okay, we set this to be 0. And what you get is x is 0. When x equals 0, y equals 1. Clear. Okay, so only get 1 point. Is this a point inside the unfortunately, this is the point on the boundary. Yeah, let's look at the boundary, okay? It's x is between 0 and 3. Y is between 0 and 2. So this is a D. Where's my critical point? X equals 0, y equals 1. So this is a critical point, right? But this is on the boundary. It's useless. We only needed to know, yeah, if this is a critical point inside the domain, then you have to look at the value of function at the critical point. Okay, right now it's on the boundary, so it's not useful. We only need to look at the value of function around the boundary. Around the boundary, yeah, you can evaluate it, but this will be not useful. F01, it's not going to be useful. It's 0 squared minus 2 times 0 times 1 plus 2 times 0. It's 0. Okay, so it's 0. We have to look at the value function around the boundary. So we have to check when along the x-axis, we have to look at several things, right? When x is between 3 and 0, y 0. Okay, that's the first part, the lower part, right? F of x, y is going to be x squared minus, it's plus 2x, okay, y 0. But when you look at this, I think I can express it at something like that. So the function, what is the maximum value? What is the minimum value? I think the function has the lowest point. Look at the graph. The graph of this function, it's going to be like that. When x equals those, this is a parabola. So clearly, the value of the function, the smallest value is going to be 0. The largest positive value is when x equals 3. 3 plus 1 is 4. 4 squared 6. 16. 16 minus 1 is 15. Okay, so the value of the function is between 0 and 15. So we know the largest positive value is 15. Second, when y equals 2, you have to do that. Okay, so in this case, you get x squared minus 2x times 2 plus 2x. So I get x squared minus 2x. Okay, but this will be slightly different because the graph of this function is going to be and here's 2, that's a 3. Okay, so the value of the function has a negative value when x equals 1. When x equals 1, 1 minus 1 it's negative 1. When x equals 3, so that will be when x equals 1. When x equals is it 2? Okay. When x equals 1, I get a negative 1. When x equals 3, I get 3. Okay. So the lowest value is negative 1. The smallest value is negative 1, and the largest positive value is 3. So you do need to look at all the possible values around the boundary. Okay. The next one will be x equals 0, y is between 2 and 0. That should be the easy part because in that case, I think when x equals 0, it's identical 0. Okay, no problem. The fourth case is when x equals 3, y is between 0 and 2. So in that case, x equals 3 squared minus 3 times 2 times 3, y plus 2 times 3. Okay, it's a linear function. When x equals 3. So it is going to be 9 minus 6y plus 6, 15 minus 6y. I have to look at the largest possible value and the smallest possible value. So I think it's clear that it's a linear function. So when x equals 2, That's the smallest value, 15 minus 12. When y equals 0, it's 15. Okay, so the function has a value between 3 and 15 on the one side, and the function can be 0, right? And the function can be between -1 and 3. The function can be become 0 and 15. I think the absolute minimum value is going to be -1. It's going to be -1. Okay, the absolute maximum value is going to be 15. So that is you have to look at the value of the function around the boundary. Now it's possible you are given a circle. Right? If you are given a circle, how to do this problem? You probably have to use the Lagrange multiply to get the maximum value of the function around the circle, because the circle becomes a boundary, right? So my question is, trying when you get home, okay? Try this, try to solve the problem when b equals x squared plus y squared equals because 0, 1 is only in point, equals 4. Okay, got it. So equals 4. Maybe you can solve the problem because 0, 1 is going 0, 1 is going to be the critical point inside the circle, but you also have to find the maximum value or minimum value around the circle. Square is easy. Square is complicated, but it's easy because each time you get a strict line, you have to have 4 cases here, because for the triangle, you have to look at 3 cases along 3 sides, right? For the square, you have to look at the 4 sides. Now, I cannot discuss number 7 and 8. I don't have enough time. I will put the solutions to the end of my lecture notes and post it, okay? Maybe this late afternoon.